Hi, my name is Boyin Yang, and I'm here to give you an overview of my third-year project, Criminal Social Network Analysis, Secrecy versus Efficiency. As it is an interdisciplinary project, I've worked with Dr. David Redherd from Computer Science School and Professor Martin Everett from Social Science School. At the beginning, I'd like to introduce what a covert network is. This is a picture taken from the movie Godfather. As we know, there are two core members in mafia. In such organization, members may keep their identities secret because the activity they involve may be dangerous or illegal. We call these communities covert networks. And here is an example of covert network, which represents the 9/11 hijackers terrorist group. Each node represents a terrorist, and the edges between them are the relationships. My tool is built to verify two hypotheses. First, covert networks should have high secrecy and efficiency level. Second, we can use optimization techniques to generate such covert networks. Now let's see how the tool works. Here is the user interface of my experimental tool, which separates to three parts: randomly generated network and imported network analyzer, and also covert network generator. We will see imported network first. Now we import 9/11 hijackers network and analyze its efficiency and secrecy. Here we use an algorithm to simulate the process of delivering a piece of message to measure the efficiency. Hours per pass is the required time for each delivery. For secrecy, users can choose one of the three key player finding methods, where key players are the most important members in a network. Degree method assumes that the importance of a node is depending on the number of its neighbors. Closeness method defines the importance of a node by comparing the shortest distance from one node to all other nodes in the network. Betweenness method assumes the importance of a node by considering all the shortest paths in the network. Then the more such paths go through a given node, the more important that node is. Let's run the tool now, and I will explain the rest concepts while it is running. This dynamic graph shows the process of measuring efficiency. We can see the red node is the information source, then it passes the message to its neighbors, and these neighbors pass message to their neighbors until all nodes receive the message. And we count the steps. This dynamic graph displays the process of measuring secrecy, which try to take out a node from the network in each attack turn. These two purple nodes are the key players that have the highest betweenness value among others. The percentage number on each node are the arresting probabilities, which are calculated by the key player's arresting probability and the distance from one node to its closest key player. In each attack turn, it calculates and sorts the probability, then select a node to be removed, which is the light red node in the graph. Once a node is arrested, it may leak information about its neighbors, which increases the neighbors' arresting probability. They are the dark red nodes in the graph. The secrecy measuring stops when the network is segmented to small isolated parts. Then we can see the results in a dialog window. It takes 43 attacks to destroy the network, and it takes 2.5 hours to pass the message to all other nodes. Then let's see the randomly generated networks. We provide 5 network models here, and choose preferential attachment with Bernoulli model, which simulates the random network in real life. We use default parameters, and this is how it looks. We can modify this random graph to construct a covert network. Now we set the preferential attachment with Bernoulli network as an initial network. Then we use one of the 3 covert network generation methods. The fast and faster method are using greedy algorithm. They both go through all the edges in the initial network by the following means. Fix one end of a random edge, and move the other end to a new position. Then calculate the combination value of efficiency and secrecy. If the value gets better, record this movement. For the faster method, it will turn to check the next edge directly. But for the fast method, it keeps checking other positions, and the best movement will also be recorded. Then apply this mechanism to the rest nodes. It stops when each node has been checked. Moreover, the accurate method, which is based on the brute force algorithm, undertakes a more sophisticated process. It keeps finding the best position for every edge until the combination value is convergent. Meanwhile, we can adjust the performance between secrecy and efficiency to influence the combination value. Then we simply run the program. Now we can see it generates a Covert network which is more efficient and secret than the initial one. And these two are the initial network and the result network. I've used this experimental tool to perform many experiments, and I'd like to show you one of the interesting results. We compare a random network and a real Covert network with same size and similar density. We found that the Covert network requires more steps to deliver message to all members, but it is harder to be destroyed. In other words, Covert network may sacrifice a few efficiency and gain more secrecy. For the user evaluation, I had a seminar with social scientists in Mitchell Center, and positive feedback is received. Thank you for watching.